In previous lessons, we would find the roots, the solutions, zeros, x-intercepts, when given a polynomial function. And we would use all kinds of strategies. We would graph it, we would divide out what we saw using synthetic division or long division if necessary, and then we would use the quadratic formula. Sometimes they factor. There's all kinds of strategies for finding the roots of a polynomial function. Well, now we're going to give you the roots and you have to write the actual function itself. But first, let's start with this example. We're going to go back to some old vocabulary. We're going to state the degree, the leading coefficient, and the roots for each of these polynomial functions. Let me grab a pen. What color do you want me to grab? It's a video. You can't provide feedback. If you said blue, you're right, though. So we're going to have our degree. We're going to have our leading coefficient, and we're also going to have the roots. And we have a lot of work to do on this one. I might have to use an extra piece of paper for something. So, all right, here we go. We're going to state the degree, leading coefficient, and the roots for each of these. I would like to think that it's going to be fairly obvious that you could look at this and tell what some of the roots are. For example, if I was to look at this, I'd say, all right, what's the root? And we're going to get in this old habit where we'd say, well, x minus 4 equals 0, so x equals 4, okay? X equals 4 is one of the roots. We still haven't talked about the degree or the leading coefficient, but we know one of the roots. And you see that squared up there. What does that mean? Well, let's start graphing it and we'll see what it means. So usually you graph on Desmos, but based on the way I'm recording this, I'm just going to graph on my graphing calculator. I have typed this function in, and you see it, and there it goes. So here we go. We have a root at 4, x equals 4, so 1, 2, 3, 4. We also have a couple other roots, and there they are, and we don't know what they are. And if we were on Desmos, we could click and find out what the decimal is. But we're going to use some strategies that we've used in the past. So 4, and I want you to notice the behavior of what happened here at 4. It didn't just pass through the x-axis. Okay, so like this one passed through the x-axis. This one actually bounced off the x-axis at 4, and I want to point out why. This one technically is what we call a double root for that reason right there. So you know this, but whenever you are squaring something, then you basically have a parabola. And so because of the squared, at this general area, it's going to look kind of parabolic. It's going to bounce off at 4. Just throwing that out there. There's more to that, but we'll get to it later. So what I'm really going to do is take each factor and set it equal to 0. I'm going to use green because I feel like it. Now, I'm going to go for the obvious on this 4. If you don't need to write this down, I'm totally cool with that. So we're going to set this factor equal to 0. We'll square root it. We have x minus 4 equals 0. I would do plus or minus, but it's 0. So x equals 4. All this can happen in your head. We already knew that. We could get that from graphing too. But we're also going to do x squared minus 7 equals 0. And we're going to bring the 7 to the other side. X squared equals 7, and so x equals the square root of 7, which is fantastic. But when we square root, we do plus and minus in the process of solving. So we have roots at 4 and at 7 and, square root of 7 and negative square root of 7. So our roots are at 4 and plus or minus the square root of 7. Okay, in previous problems, previous lessons, we have had this little thing where we said, oh, how many answers do we have? 3, 1, 2, 3. How many answers do we have? 3, 1, and then the plus is an answer and the minus is an answer. So 3 here. How many answers do we have? 1, 2, 3. Well, we haven't even talked about the degree. I wonder what the degree of this is. Okay, very quickly on a separate piece of paper, and you do not have to write this, but on a separate piece of paper, I'm going to take this from the form that it is, and I think this is worth writing down. What we're looking at right now is factored form. And if we put this in standard form, then we'll really be able to answer these questions. These two questions, these two things come mostly from standard form, and I didn't leave enough room to put this in standard form, and I am going to go very fast on this. So speed it up even more if you want to, but here goes. What I'm going to do is take this equation, I'll just stick with the red pen, and we're going to have f of x equals x minus 4 squared. So I'm really going to write it twice, and then we'll put x squared minus 7. And we're going to just multiply, multiply, multiply. You can use the box method if you want. I'm not. So I'm going to have x squared minus 4x minus 4x. That's minus 8x. And then plus 16. That gives me the first ones. And then we're going to have x squared minus 7. So then we'll multiply all this together. So here goes. X to the 4th minus 7x squared. Okay, move here. Negative 8x cubed. Things are out of order here. We'll deal with it later. Plus, that's an awkward plus sign, 56x plus 16x squared minus 16 times 7. I'm having a brief moment of panic trying to figure out what that is. That is 112. There we go. And we're going to put this in descending order. So x to the 4th minus 8x cubed, 9x squared, 56x, and negative 112. And this is what the function is equal to. So now we can actually answer the question of the degree and the leading coefficient. So your question probably is, do I have to do this every time? No, actually. I'm going to kind of show you a shortcut-ish looking thing. And again, this is not necessary every time. The degree is 4, and we could have found that from the very beginning by saying, oh, I have x squared here, and I have x squared here, and therefore, they're buffing the floor outside the room while I'm recording this, and that's what that sound is, if you hear it. I'm not sure if it's coming into the video. The degree is 4. So the highest exponent you will see if you multiply this out and put it in standard form, now they're slamming my door. If you put it in standard form, it would be 4. So the leading coefficient is 1. There we go. Leading coefficient is 1. So how can you tell that without going through this whole process? Not always obvious. But again, we have x squared here and x squared, and then the 2 plus the 2 gives me that 4. So let's back up a little bit. Previous lesson, one more time. I should have 3 answers, and I do. I should have 4 answers, and I don't. I have 3. Well, here's why. This one is a double root. And you don't have to write that on every single one of them, but I think it's worth writing, and let's put it in purple, just for fun. Let's use almost all the colors. This one is a double root. And again, just to give you a visual, here's what that looked like. Bounced right off the x-axis at 4 instead of passing through it. Okay, let's move to the next one. And we'll continue this idea. We need to state the degree. And we will do this one, hopefully without having to figure all that stuff out and multiply it out. And the leading coefficient, and we're going to get our roots. Okay, our degree, let's kind of count carefully here. We're looking at the exponents of the x's, and we're going to add them together. Okay, again, x squared, notice 2 fingers here, and then x squared, and that's why it's 4. Here we have x to the 1st, 1 so far, 2 more here, and then 3 more here. That gives me 6. I know you're like, oh my goodness, I can count to 6. I hear you. Just be careful, because sometimes it's easy to overlook pieces of it, as obvious as it may seem. The leading coefficient, you might say it's 4, and you would be right in this case. However, if you had another number in the front here, like another number like in front of the x squared, or if you had another number in the parentheses here with this one, we'd have to multiply a lot of stuff out. But if, that's an if, we're not going to do it, but if you multiplied all the stuff out, you would end up with 4x to the 6. So the leading coefficient is 4. Lucky us, it was staring us in the face the whole time. The roots. I wonder what the roots are. Okay, well, here we go. Let's switch colors one more time. If 4x equals 0, whoops, where's my whiteout? There you are, whiteout. If 4x equals 0, then x would equal 0. You can do that in your head. If x squared plus 16 equals 0, your first guess might be 4. I hear you. Let's work with that. We'd subtract 16 from both sides, and we'd take the square root of negative 16, and we'd take the square root of negative 16. Let's play with imaginary numbers for a minute. The square root of negative 16 is 4i, because we took the square root of a negative number, and we do have plus or minus. And then we have the x minus 5 equals 0, and it is to the 3rd power, so if you want to go through that process, you can. And we would take the cube root of 0, which is 0, and we'd add 5, and we get this. So we have 1, 2, 3, 4 roots. We should have 6, but we don't have 6. We only have 1, 2, 3, 4. We'll be all right. So 0 plus or minus 4i. Now technically that's not going to show up as an x-intercept, okay? The imaginary axis, and yes, that's the thing, The imaginary axis doesn't show up on a standard graphing calculator. It would have to be multi-dimensional for real. It's amazing. Great YouTube videos about it. Watch it for fun. So the degree is 6. I have 4 roots, but I'm supposed to have 6. Just like I had 4 roots, but I really had 3 here. It's that kind of thing. So we're going to graph this one and see what happens on that. So that was the first one, very first problem. I have typed it in. It's ready to go. Let's press graph. And we should cross the x-axis at 0 and at 5. There it goes. This one isn't looking like I want it to. I'm going to adjust the window. You don't have to know how to do what I'm doing right now. I'm just fixing it to where it'll look the way I really want it to look. Oh, please work, please work, please work. Let's go a little bit. A little bit further out. There it is. Okay, okay. I'm gonna do this one more time. Sorry. I just find it necessary to really demonstrate what's happening here. Whoa, that didn't happen the way I wanted it to. Hang with me for just a second. Now we're seeing it the way it's intended to be seen. I just stretched it down. Like if this was on Desmos and it was a touch screen, I would just squeeze the y-axis and squeeze the y-axis, and this is what it would look like. So we would cross the x-axis at 0 and at 5, and there's a wonderful branch of mathematics that really studies what it would look like here. Again, that's not going to show up on a graphing calculator or on Desmos. Beautiful as it may be, it's not happening here. If we had an axis that folded up in 3-dimensional, whatever, fun, not now. 0 and 5, but again, here's the dilemma. It's supposed to have 6 roots, I only have 4, only 2 of them are showing up. What about this 5? Well, it was cubed, just like this was squared, and therefore I said, oh, it looks like a parabola. Remember that? This one looked like a parabola. Well, this one looks like a cubic function. I hope you remember what a cubic function looks like. This little guy right here is what we call, wait for it, a triple root. There we go. All right, that's going to give us a good push in the right direction as we move forward.